In this video, we're going to look at the history of the atom and how our understanding of the atom has evolved throughout the years. Now, the first mention of the atom was in 460 BC by a Greek philosopher called Democritus. So he wasn't a scientist, he was a philosopher, and he came up with the theory that basically if you had something, for example, a metal, and you cut that metal in half and then in half again and in half again, eventually you would get to a point where you wouldn't be able to cut that metal up any further without it stopping being the metal. And he called these indivisibles, or in Greek, atomos, which is where the word atom comes from. And so they're extremely small solid particles, and they were spherical in shape because the sphere is one of the perfect shapes in philosophy at the time. So these little small solid spheres that make up everything. Now this theory lasted a very long time. It wasn't until 1808 that Dalton, still using this theory, actually was able to, through experiments, make a list of all of the known elements, as well as calculating weights and properties of those elements, and even predicting some elements that hadn't been discovered yet. In 1903, J.J. Thompson was the first person to actually change the model, and he came up with what we refer to as the plum pudding model. Now, the reason that it needed to be changed is because they discovered electrons, and they didn't know where the electrons fitted into the model. So the plum pudding model is that there is a positive ball or a positive pudding with negatively charged electrons floating around in it. So they're just distributed randomly throughout the atom. The gold foil experiment is a very famous experiment that Ernest Rutherford conducted. And what he did is he got a piece of gold foil, very, very thin gold foil. Gold's quite malleable, so he was able to get the gold foil only a few atoms thin. And what he did is, using a radioactive source, he shot at that gold foil alpha particles. Now, what he was expecting to happen is, because these, going from the plum pudding model, these solid balls, solid positively charged balls with the electrons inside them, these particles that he shot from the radioactive source would all bounce off. So he'd see the fluorescent screen fluoresce from these reflected or bounced particles. But this wasn't the case. What he actually saw was that the majority, and this is the vast majority, of these radioactive particles actually went straight through the gold foil. So he had to therefore change the structure, and he came up with a major change, that there was a small dense nucleus with electrons orbiting around like planets. So we call this the planetary model, and with the majority of the atom actually being made up of empty space. So you've got a very small, very dense nucleus, and then that's surrounded by orbiting electrons. In 1913, Niels Bohr came along and changed this model again slightly. Rather than having the electrons orbiting around the nucleus, he had them orbiting in definite or quantized energy levels. So the first energy level, there was able to be 2 electrons in it, then another 8 electrons were found in the second energy level, and so on above that. So we have again the nucleus, positively charged nucleus, with the electrons surrounding it, this time in quantized energy levels. In 1932, Chadwick had to change the model again, and this was because neutrons had been discovered. And so he changed it to put the neutrons in the nucleus. So the neutrons and protons are found inside the nucleus. He left the electrons pretty much unchanged from Niels Bohr in their quantized energy shells. So he pretty much just changed how we see the nucleus. And this is the current model of the atom that we use today.